Hello and welcome to this Vision Channel session. My name is Heiko Seitz, and today I'll take you behind the scenes of our wide range of standard vision cameras. But I'm not going to introduce a new camera product in this session. It will be much more about opportunities getting exactly the camera you need for more specialized, in other words, customized projects. So the topic now is about unique requirements and the corresponding unique solutions that we can offer you economically. Yeah, to begin with, a few words about our development and experience as a manufacturer of industrial cameras. When the idea starts in 1997, it was all about PC frame grabbers for analog cameras. And then we developed the production of digital USB and Ethernet cameras from scratch, and where we were able to launch the first USB 2 industrial camera with CMOS sensor in 2004. We started the camera production in a small room of about 20 square meters, and today we have a highly flexible camera production facility at our site in Obersulm, where we develop, manufacture, store and ship around 3,500 different models in series economically and with high quality, completely made in Germany. With this in-house development and departments for production equipment and tool making, we are now able to handle customer projects with a wide range of requirements for projects that are realized with standard cameras. We can deliver quickly from stock and guarantee long-term availability with our versatile portfolio of standard cameras from a quantity of one, but also for large volumes. On the other hand, we have also retained the flexibility to design and any type of customized camera in terms of connectors, housing, interfaces, or camera software. And thanks to the ability to develop and build special production tools for each type of special component ourselves, we can adapt our camera production as required in order to also produce fully customized camera economically in higher quantities. And to close the gap between these standard and customized cameras, we have created a modular camera kit that allows you to configure, plug in and quickly try out a wide range of board level variants, and with numerous image sensors, interfaces, and extensions and expansion boards. We will see more about this in a moment. So even the standard cameras can be customized in all families, from low cost to the high-end cameras. Specific modifications or customer requirements compared to the standard versions are possible on request. In addition to the standard variants that are always offered, such as housed and board level versions, it is also possible to include new image sensors in the portfolio. And furthermore, small modifications in the camera device info memory are also possible in order to specifically name or mark the camera for the customer software. And these cameras are then simply programmed differently in the production process. So customer-specific branding or logos on the camera housing are also feasible. Different connector configurations, for instance, for digital inputs, outputs on our single board cameras are also easy to realize. And in addition to C, S or F mounts, we also offer modified camera fronts for optics, for instance, with auto-threaded flange, and as you can see here in this example. But what if, for example, when the space for a camera or a complete camera electronics and the optics and the connections does not fit in your device, and there is also no standard camera that is small enough for this? This is where we start in the area of customized hardware and software development. If a standard solution is not an option for an application, our experienced developers come into play. We can make almost anything technically possible for higher volume projects. So specialized developments that we have already realized for our customers include, for example, changes in the appearance of the hardware, as I just mentioned before. And however, this may also include a customer specific or branded user interface for the camera software, and far more complex on the other hand are changes to the design, including the shape of the housing or also the circuit boards. And customized connector types or orientations are also very common. In addition to the interface connectors for USB, Ethernet and IOs, this also includes the connections between the individual boards, also known as board-to-board connectors. And of course, we also implement special functions. This may be the control of an additional feature, or a hardware unit such as a motorized lens, a special trigger mode, or something like that. And last but not least, changes to the electronics. So alternative chips, the power supply, basically everything that makes a redesign of the electronic circuit boards necessary. For any changes to the camera hardware that do not correspond to our standard assemblies, we naturally also immediately focus on the feasibility and production of the new parts. However, with our highly adaptable production, our own department for equipment and tool making, we are also able to efficiently produce special cameras in high quantities and in serious quality. And in addition, with our own assembly system, our own EMC measuring cell, we are very flexible, especially in prototyping, and can react quickly and perform development loops very fast. With our own measuring equipment, which is not necessarily a given for companies in our size, we can always keep an eye on important values for electromagnetic emission, throughput of the data lines, or other important device parameters. Nevertheless, customized developments are naturally more time consuming and cost intensive than stock products, and therefore only make sense and are economically viable for both the customer and IDS once a certain number of units have been produced. In order to avoid starting from scratch with every special project, and thus speed up the time to cost of the first camera test, we have designed a modular system with the UI ACP. For this purpose, the most important camera assemblies, such as the sensor boards, the interfaces, optics, options, and so on, have been developed as plug-in standard modules that can be combined as required. It consists of the two base boards for USB 3 vision or Gig vision, several connection options for the desired sensor boards, and various interface boards. The image sensor boards can be, for example, be connected via the direct board-to-board connector with a flex cable in various lengths, or also with a lens carrier. And there are also direct pluggable or detached interface boards with USB plugs, RJ45 or M12 plugs for even without a standard plug if you want to use your own connector electronics. The advantages of using the ACP assemblies are obvious. Flexibly configurable board level cameras for customized device designs available immediately from stock. This means you lose no time. The prototype development can start without a delay, and there are no additional costs for specialized developments or equipment for special camera parts. The ACP can be supplied in individual parts. So for you as a customer, this means that you do not have to disassemble the camera in order to install it in your device. Normally, cameras, regardless of their design, are completely pre-assembled, tested, qualified, packaged and dispatched as a unit. And all standard ACP assemblies, on the other hand, can be individually contacted and fully tested with our self-developed equipment. even in large quantities, without having to fully assemble them. So this minimizes the impact on the components and connectors and saves customers time. It also makes a possible replacement of individual parts in an RMR process much easier. Yeah, and the UACP is also a good starting point when a more customized solution is required. For example, a longer sensor connection as a flex or a hard PCB, or perhaps a baseboard with additional components, such as a switch or USB hub. Here is a small but very interesting application example to give you an idea of these customizable options. A dual-headed UACP. Let's take a look at the development stages of such a project, how it come to life. Let's assume you have the plan for a device in which two cameras should inspect one object from different angles. In a first step, during the pre-development of the application functionality, you could, for example, work with two USB 3 standard cameras connected to a standard USB on a PC. Once the function has been ensured and you move to the device integration of the camera electronics, you could design in the same standard cameras into your housing as board level variants if necessary. But maybe there is not enough space in your case for the complete camera electronics where the sensors are to be placed or located. Then you can use the same camera components as ACP standard assemblies from stock. This means we are already very flexible when it comes to positioning the assemblies in the device. So it's also possible to use long flex connectors to detach the sensor boards from other PCBs, which are also available from stock in various lengths. To reduce the interface cables of your device, also an USB hub could be integrated in the housing, or perhaps even a special ACP baseboard including such a hub could be developed. But with the ACP assemblies, there is a much more efficient way that is far less complex than it might seem to be. The idea is to use only one ACP baseboard and combine it with an Y adapter for connecting the data lines of the two sensors to the FPGA on this baseboard. And in addition, we now add a small firmware modification for the ACP baseboard, the FPGA, to capture images from both sensors and stitch them in one camera image. And with these little modifications, a completely new camera is formed. Here you can see a prototype of this option that we have developed to show the advantages of the ACP as a base for such special projects. The two sensors are connected to the standard ACP baseboard via the custom developed Y adapter board, where the data streams are simply combined into a single white image by a firmware upgrade of the integrated FPGA. The trick is to simply do a two-step pixel binning in horizontal direction, and the resulting image has the same size as a single sensor in full resolution and can then thus be handled by the camera software as a single standard camera. So with this small additional board and a custom firmware for the ACP baseboard, a twin-eye camera arises. And for example, for a stereo 3D application, or simply to obtain two viewing angles of an object with the same data volume as one camera. Yeah, and by the way, these twin-eye mods for the ACP standard kit can also be ordered on request. So if you are working on such a project or you are interested, it is definitely worth taking a look. So then we've come to the end of this talk, and to summarize once again, the development of customized cameras for special projects can be very time consuming and cost intensive. It is important to have a partner who not only has the know-how to realize everything, but can also offer solutions quickly, flexibly, and economically in a desired quantity and quality. IDS develops and produces all cameras at its site in Obersulm, and we are able to design and build our own equipment, including for the production of special cameras, and then therefore guarantee the quality of standard series cameras, even for small quantities. We have our own assembly line for fast prototypes and our own EMC measuring cell to efficiently and quickly test and optimize the required limit values for every new camera development. And with our UACP modular system, we also have a good starting point for producing high quality customized cameras quickly and in any quantity. Yeah, and to lose no time, we have now also launched a new landing page with the UACP infos and a direct link to the new simplified ordering process, because the camera is now available directly over our web store, which I can also briefly show you online. So when you come directly over our website, from the start page, you can search here for the new UACP infos and click on learn more, and then you directly come to the new UACP landing page with all the infos and benefits for this camera, configurable camera. And then as you want to test one of these configurations, then just click on configure here and you directly come to the camera finder with pre-selected UACP camera family. Select one of an interesting sensor for your need, and then you have the chance to choose one of these. What about 56 different variants with or without CMOS optics carrier? And we choose one of this, and then we also we have here the color version pre-selected. You can also use the monochrome, and then about configure here you directly come to the configuration options, where you can choose the camera interface. You may have the chance to use the 40-pin Semtech connector on the baseboard with your own electronics connections, or use the two options for connecting with a flex cable, the RJ45 or the M12 plugs, and the same for the sensor board using different length extensions for detaching the sensor board. You see also the price when you are logged in and when you have a registered account for this, and then you can put it in directly to your chart and see, and here you can view your chart, your card, come directly to. I have also two cameras in it, so you can also configure and deselect what you don't need or you need, and you have the chance to select more quantities if you need 2 or 3 or more cameras from this variant. And then it's easy to update and proceed with the checkout using PayPal or our other payment options. Then we are at the end. As you see, the UACP is very easy to configure, easy to buy over our web store. It comes from stock to you very fast, so with no delay you can start your customized developments. At this point, I would say thank you for listening. Goodbye at this point, and I look forward to welcome you in one of the next Vision Channel sessions. And in the meantime, come to our website, look in the Vision Channel portal, and there are also many other interesting topics to watch on demand. So then, thank you. Bye bye.